Hi guys, I'm here today to explain your topic calculation of charge. So most of the people feel that or the students calculation of charge is a very important thing and they feel it difficult. But today I'll solve it with the easy method. Okay, let's begin. Today's topic calculation of charge. Let's consider an element oxygen. Atomic number of oxygen is 8. We'll write the electronic configuration of oxygen 1s2, 2s2, 2p4. And how to calculate this electronic configuration I have told in the past video. You can watch that video. Okay, so this is the electronic configuration 1s2, 2s2, 2p4. So there are two types of stabilities: duplet stability and octet stability, or you can also say octet configuration or duplet configuration. Okay, I'll write it: duplet, octet. There are two types of configurations, or these are also known as two types of stabilities. So to find the charge of an atom, we have to consider that we have to find the last shell of the particular element. So these are the shells: 1s, 2s, 2p, 3s, 3p, 3d. For example, I have written this. So in this is the first shell, and these two are the second shells, and these three are the third shells of that particular element. I have just considered this as an example, so let's practically do that. Okay, now I am considering here. I'll write, is it visible? Okay, yeah, it's visible. Okay, I'll consider an element carbon. Okay, atomic number of carbon is 6. The electronic configuration of carbon is 1s2, 2s2, 2p2. Am I right? Yes. Electronic configuration of carbon is this. Okay, then last shell of this carbon atom is 1 and 2. This is the last shell. This is the second shell is the last shell of the carbon atom. So how many carbon atoms are present in this last shell? 4 atoms. Octet means 8. Duplets means 2. Okay, remember this. So there are 4 electrons present in carbon, and to attain octet configuration it has to gain 4 electrons. And for the duplet configuration it has to lose 2 electrons. Okay, now I'll explain you what is gaining of electrons and losing of electrons. Yeah, now gaining of electrons: when an element or an atom needs some electrons, if it is indicated with the sign of minus, that it indicates that it is gaining some electrons. If it is indicated with the sign of positive charge, it indicates that it is donating some electrons to another atom. So by donating and gaining of electrons, particular atom or particular element attains stability. So I believe that most of you students find that like this: oxygen -2, carbon -6, etc. something, okay, and you guys have doubt that how this charge is being get. Okay, now I will solve this. So let's consider an element sodium. Symbol of sodium is Na, and its Latin name is nadium. Now let's write the electronic configuration of sodium: 1s2, 2s2, 2p6, 3s1. Atomic number of sodium is 11. Now there are 11 electrons which are accommodated in its shells, and there are how many? Let's observe how many shells are present: first shell, second shell, third shell. In third shell there is only one. In this last shell or the valence shell, last shell is also known as valence shell, and the electrons which are present in the last shell are also known as valency electrons. So this is the last shell. So I'll write the symbol of sodium. How many electrons are present in the last shell? 1 electrons. So to attain duplet configuration, it should gain 1 electron. Or to attain octet configuration, if it loses so this 1 electron, this complete valency shell will be cancelled, and this will become the last shell. If this becomes the last shell, there are totally 8 electrons. If it loses this first electron, it gains octet configuration. So better to lose this electron. So I'll indicate with Na. I have said you that donating means plus, and gaining means minus. Okay guys, Now here there are 11 electrons present. If I donate this one electron, last shell they get octet configuration. If I am donating the electron, that indicates I am writing the symbol of sodium. If I am donating the electron, indicates plus. And how many electrons I am donating? 1. So the charge of sodium is plus 1. Okay, did you guys get that? So we'll try for another element. Now I will consider sodium, magnesium, aluminum. Okay, I'll take aluminum. Sorry guys. Symbol of aluminum, Al. Atomic electronic configuration, and first we should find out the atomic number. Atomic number of aluminum is 13. And I'll write the electronic configuration of aluminum: 1s2, 2s2, 2p6, 3s2, 3p1. Guys, if you have doubt regarding the filling of electrons and regarding these orbitals, please watch my past video which I have done. Okay, 6, 8, 10, 12, 13 electrons are accommodated in these shells. Now let's see the last shell. This is the first shell, second shell, third shell. There are 3 electrons which are known as the valency electrons that are present in the last shell. If it loses this last 3 electrons, it can gain octet configuration. If it also here we you guys can get a doubt that here third shell is the last shell and there are 3 electrons present in it. So if it gains 5 electrons also, it can get stability. Gaining of 5 electrons for aluminum is it's not a simple thing. Gaining of electrons needs loss of energy. More amount of energy is needed for this aluminum to gain 5 electrons from other shell. So many of the atoms are not ready to donate some kind of electrons. So here these 3 electrons can be donated rather than accepting 5 electrons. If these 3 electrons can be donated, this complete shell will be cancelled. If this complete shell is cancelled, there are 8 electrons completely present in this valency shell. So I'll write the electronic configuration once again: 1s2, 2s2, 2p6, 3s2, 3p1. So I am completely donating. There are 13 electrons. I am donating these 3 electrons. So there are 10 electrons present. So I will cancel this. After donating, this is the electronic configuration of aluminum. So let's observe the last shell. In this last shell, there are 8 electrons present. So it is according to octet configuration, it becomes stable. So symbol of aluminum, Al, and it gained or donated the electrons. It donated the electrons. So we use plus symbol. And how many electrons it donated? 2, 3. So okay, observe. Guys, pay attention. 2 electrons, 1 electron, 3 electrons, completely 3 electrons it has donated. So we use symbol Al plus 3. Okay, did you get the calculation of charge? As you go of crossing the elements 10, 20, 30, some of the conditions will also occur. So we'll try that. Is it clear? And next, some other element. We'll consider okay, now I'll take hydrogen. Electronic configuration of hydrogen: 1s1. How many electrons are present in what is the valency shell? We should first find out the valency shell, and that is one and foremost thing we have to identify. First find out the valency shell, then we have to find out the valency electrons, then we have to donate or accept according to the stability. That depends upon your observation. Okay guys, see, there is only one electron present in its valency shell. So now gaining 7 electrons is a huge thing. If it need to gain 7 electrons, it needs lot of energy. So it can also gain, if it gains 1 electron, less amount of energy will be needed for hydrogen. So hydrogen tries to gain 1 electron. If it here 1 electron is present, if it gains one electron, so it becomes duplet configuration. Okay, the electronic configuration of hydrogen is 1s1. If it gains 1 electron, then hydrogen symbol, hydrogen does not have stability position in the it is not stable according to many laws, and it does not have stable position in the periodic table also. And some people says that hydrogen can donate first electron, so total number of electrons in the valence shell becomes 0 and it can become stable atom. And some of the people say that it can take one electron by giving some amount of energy, so its electronic configuration becomes 1s2, and it can be denoted with this symbol, or it can also be denoted with this symbol. I suggest most of you to do this. According to while avoiding this method, we can suggest this method. Okay, electron charge of hydrogen is always +1. Okay, I'll explain you that also. Electronic configuration is 1. Okay, got it. Minus means it's gaining, plus means it's donating. Is it clear, guys? Okay, here +1. So there is only one electron. If it donates this one electron, the total number of electrons in the valence shell becomes 0, so it becomes stable. Okay, so we indicate with the positive charge 1. Now I'll take another atom. We'll consider boron. Okay, boron. Electronic configuration of boron: hydrogen, helium, lithium, beryllium, boron. 5. I'll write the electronic configuration of boron: 1s2, 2s2, 2p1. So find out the last shell. This is the last shell. The total number of electrons present in the last shell: 3 electrons. So here to get octet configuration, it needs to gain 5 electrons, or to get duplet configuration, it need to donate 1 electron. Do you get that, guys? The total number of electrons in the valence shell is 3. So to gain octet configuration, it needs 5 electrons. This is for octet. Do you get that? And for duplet configuration, it need to donate 1 electron. Here it should gain, and here it should donate 1 electron. Gaining 5 electrons is foremost thing that it needs more amount of energy. Rather than that, it like to donate some electrons. Okay, now charge is 2 and 1, 3 electrons. If it donates one electron, charge will become -1. How? I'll show you. Symbol of boron B. It is likely donating 1 electron. Donating means I have sorry guys, sorry. Donating means I have said you we have to use the symbol plus 1. Now the total number of valence electron present in this are 3. If it donates 1 electron, it becomes the last shell becomes second shell. The total number of electrons present in the second shell are 2. Okay, now it becomes boron is stable with duplet configuration. Okay, now let's try another example. Which element shall we try? Copper or zinc? We'll try zinc. Atomic number of zinc: hydrogen, helium, lithium. Okay, argon 18 becomes argon, potassium, calcium, scandium, vanadium, titanium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Okay, let's try with zinc. Atomic number of zinc is 30. Now I'll write the electronic configuration of zinc. It's too big, but we can write. Zinc: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. So guys, I hope that you have remember the order of this writing the electrons. I have done it in the past video. Okay, now see, 10 electrons, 12, 14, 20 electrons, 26, 28, 30. Overall 30 electrons are being accommodated. Now let's find the highest shell or the last shell. First shell, second shell, third shell, fourth shell, and third shell. This electronic configuration, there is a particular order for this electronic configuration. I have said it. Okay, hope you remember that. So find out the valence shell. Valence shell is the fourth shell with electronic configuration this is the valence shell, fourth shell. So the total number of electrons present in the valence shell is, let's find it out, and 2. These are the total number of electrons. These are the total number of electrons present in the valence shell. 2 electrons. Here, if we donate these 2 electrons, the total number of electrons that are present in the zinc atom will be 18 electrons. So last shell 8 electrons are available. 1s2, 2s2, 2p6, 3s2, 3p6. I have donated this, and 3d10. 10 electrons, 6 electrons, 18 electrons. The total number of electrons are 18 electrons. It is also considered as octet configuration. 8 or either 18 are considered as octet configuration. Duplet does not have anything. Duplet is considered as only 2 electrons are present, and most of the element does not follow duplet configuration. Only some of the elements like boron, which are which have atomic number below 5 or 6, will follow the duplet configuration. So now, if I am donating this symbol of zinc, I am donating these 2 electrons. Donating means symbol we should use plus, and how many electrons I am donating? 2 electrons. If I am donating 2 electrons, I will write the symbol 2. So symbol of zinc is Zn plus 2. Okay guys, do you get that? Hope I am clear with that. So I am closing this video now. I will come again with the new topic. Okay guys, see you, bye.